So from reciprocity theorem we can write integral for s into ei into hj minus ej into hi into ds will be equal to 0. Let me take this as equation 1. Here S is closed surface area of the junction, closed surface area of the conducting walls enclosing the junction. This is nothing but S is your closed surface area of the conducting walls enclosing the junction. And endports. In the absence of any source, since the integral over the perfectly conducting walls vanishes. Okay, the only non-zero integral are those taken over the reference planes of the corresponding ports. What is your reciprocity theorem defines is, so this is the statement for that. If you are considering a I then j port which gives you the fields ei and hi and ej and hj. So here integral over s is the closed surface area of the conducting walls enclosing the junction and the end ports in the absence of any source, since the integral over the perfectly conducting walls vanishes. The only non-zero integrals are those taken over the reference plane of the corresponding ports. Okay, now equation 1 becomes n is equal to 1 to n integral Tn ei into hj minus ej into hi into ds. So now your integral has gone on with the summation. That is what your the only non-zero integral are those taken over the reference planes of the corresponding ports. For all Vn, for all the ports Vn is equal to 0 except we know that this one, except Vi and Vj. All voltages will be equal to 0 except for Vi and Vj. So let me take this as equation 2. So if you take this condition, So your equation 2 becomes integral, this is the I, sorry, ti into ei into hj ds. This is equal to tj, integral of over the tj in ej into hi into ds. So this is equation 3. The equation 2 reduces to this one. Now if we consider the power over your ith and jth port, you can write it as, from the equation 3, you can write it as Pij is equal to Pji. Let me take this as equation 4. So from the previous equation, that is from the equation 3, what you have, it is integral over ti ei into hj into ds is equal to integral of ej into hi into ds over tj. So this will gives you Pij is equal to Pji. So let me take this as equation 4. So where Pij is represents power at reference plane I due to the input voltage at plane J. Okay, so we are taking I and J port as reference ports here. Okay, so Pij represents power at reference plane I due to the input voltage at plane J. So from the admittance matrix representation, we can write I is equal to y into v. Correct now? So this is how we write y parameter. That is I is equal to y into v. So we know that P is equal to, we can write P is equal to v into I. Correct? So from the equation 4, that is Pij is equal to Pji, we can write it as Vi into Ij, which is equal to Vj into Ii. Now you substitute for this Ij. So you can write it as Vi into Yij into Vj is equal to Vj into Yij into Vi. Correct? So you will be getting it as Yij will be is equal to, so this is Ji. So this will be equal to y into Ji. So this is what your symmetrical Y matrix is. Similarly, you can do for Zij is equal to Zji. Symmetrical Z parameter or Z matrices. This is how to do for Z is, you have to take V is equal to Z into I. So again P is equal to V into I. So we'll be taking Vij is equal to Pji. Go on substituting for this. We'll be getting this one, symmetrical Z matrices. Okay. So here what we are taking is, you are considering an input in which We are taking incident wave amplitude Vn plus and Vn minus is reflected wave amplitude. The sum of these two will give you 0 for all the ports except for ith and jth port. So where you are taking where which produces Ei and Hi and Ej and Hj as the electric and magnetic fields. Scalar, you are taking it AR is magnetic field and the electric field for these particular ports. So these two are your reference ports. Okay. So from the reciprocity theorem, you can write this equation. Here S is nothing but your closed surface area. So that is what we said, no? So here, where this comes, the Lorentz reciprocity theorem is when you are considering a volume containing two sets of sources, say your I and J port, like which produces where it is producing the electric and the magnetic field, there you can use this Lorentz reciprocity theorem. So by that theorem you can write this equation. So closed surface area of the conducting walls enclosing the junction and end ports in the absence of any source. Since the integral over the perfectly conducting walls vanishes, so we are considering the only non-zero integrals, okay, are taken over the reference planes of the corresponding ports. Okay, now your equation 1 reduces to this. Okay, so Vn is equal to 0 for all the ports except for I and j. So equation 3 2 it becomes this one. From this you will be getting Pij is equal to Pji. So this you can write it as. So next you have to consider the admittance and again comes the impedance. So this is what your proof. This has been asked only in one examination. You can check in the previous year question papers.